All right, it's for Noah. Example 4. A hot air balloon rising straight up from a level field is tracked by a rangefinder 500 feet from the liftoff point. 500 feet from liftoff point. That's important. Wait, a hot air balloon rising straight up. That's probably important. At the moment, the rangefinder's elevation angle is pi over 4. Elevation angle. The angle is increasing at a rate of 60.14 radians per minute. How fast is the balloon rising? Okay, there's a lot of stuff to pull out of here. First, the thing we're trying to find is how fast is the balloon rising?
Why is
Literally.
it at an angle?
What?
Why is it?
It's not. So, let's draw a picture to better understand it. Ready? Here's like, this could be the liftoff point. Okay. A rangefinder, right? It is 500 feet from the liftoff point. It's also on the ground. Somewhere over here. Here's the rangefinder. Yeah. Tells you how far, so you can, it's kind of like those infrared sensors. I have this gun thing. It's not a gun. My dad had it growing up, and you just like push it, and you can like see how far it is away. Yeah. No, that's a rich person's sport. Are you kidding me? That's so expensive.
My grandpa just
Or like if you're building something. Okay.
Wait, does it have a screen?
That was me. Okay. What?
How does it know where you're pointing? Like,
oh yeah.
Because it sends out a beam of it's kind of like the ultrasonic sensors. It sends out a wave, hits back, and it's back in the reflector. And depending on how long it took to come back, because all waves travel at the speed of light, 3 times 10 to the 8 meters per second, and so it beams back and you tell exactly how far away you are. Fun fact, how long does it take for light to go from Earth to the moon?
Oh, I know the answer to this. I know the answer. 7 seconds. Wait.
I'm going for 1.
No, it's
No.
like
Whatever. Okay, I'm over
No, I
this.
think it's like over a year or something.
Nope, it's 8 minutes. Light takes 8 minutes from the sun to Earth. So the moon's in the terms of like seconds. Pretty sure it's 1.74 seconds. Will you double check me? Double check me. 1.74.
That's crazy.
How do they
I don't know anything about this.
How does that work?
Remember, and then I said 1 light.
What? You said 1.3? Both ways or single way? Single way?
Yeah, from here to the moon.
1.3 seconds. Yeah. Yeah. It takes, I think, 11 minutes from here to Mars, depending on like where we are with Mars.
Somehow it slowed down.
It does. If all of a sudden there's a black hole in between, that would warp space-time and then it would get slower. Okay.
I just got the chills. Yes.
The way speed guns work, literally, they send out a packet of information, and so they send out multiple. So it's like, oh, you're this distance apart, this distance apart, this distance, and it like finds your rate of change. So at 1 millisecond, you're here. 1 millisecond later, you're this much closer, this much closer. So it's seeing the rate of change and it can find out your speed. Roughly, that's like roughly how it works. Cool. The more you know. Let's go. Okay, let's do this. This is when I miss physics, when I just like go off about random stuff.
You really should do that.
Goodbye. I'm not talking about this. Okay. I'm talking about this. Okay, so let's list out. This is my angle, because the angle of elevation is always the angle from the ground up to the thing you're looking at. So that's the angle of elevation. Up here is our little hot air balloon. It's on my list to do. Temecula has this big old hot air balloon festival.
Yeah,
Okay, what else do we know? So it goes straight up. Literally, the balloon goes straight up. The rangefinder is measuring the angle. Okay, at a single snapshot, right? So the 500 feet is not going to be changing. It's going to stay 500 feet away from the liftoff point. The only thing that's changing is the balloon going up, and therefore its height and the angle of elevation is changing. So we can call this y, because that makes sense. It's going up and down. We have theta changing. Those are the two things that are changing. The rate of change, we know, right? D theta, dt, it's changing at a rate of 0.14 radians per minute. All right, and let's see. That is when theta is pi over 4 radians. The thing we're trying to find, how fast is the balloon rising? AK, what's our rate of change vertically? What we're really looking for is dy dt. How fast are we going vertically?
I have a question. Why would it be d theta over dt is increasing at 0.14 radians per
That's
minute?
the
What is
change in
the
angle per time. Yep.
Then, okay.
The angle is increasing by 0.14 radians. So if only there was a way to relate vertical y with theta, my angle, and using the thing we know, which is 500 feet, which is the adjacent side to my SOHCAHTOA. Which one?
Cosine.
Look at D from the previous example.
Sine. Tangent.
Tangent.
I just said look at D from the previous example.
Sine.
Look, turn your page. Turn your page. Oh my gosh.
Tangent.
Tangent. All right.
I said that.
Not.
Exactly.
Yep.
You just gotta be louder.
There.
Tan of theta is equal to y.
I don't like to share.
Sure. Tangent of theta is equal to y over 500. Because the distance between our rangefinder and the liftoff is constant. The only thing changing is our angle and the vertical height. That's the relation. And notice the 500 is a constant. Right? This person with the rangefinder, it's not moving. They're just standing there constantly. Okay. So now, literally, all we have left to do, take the derivative, plug in the things we know, and solve for dy dt. Yeah, let's take the derivative. Yeah, let's do it. Let's do it. Let's go. Take the derivative. Try it. Try it yourself. Go, go, go. Take the derivative. 500 is constant, so you can say 1 over 500 times y. Take the derivative on both sides. Okay. Please make sure the blood stops.
How do you do that though? Because it can't be over 0.
What can't be over 0?
Oh no, I thought it was 1.
Are you trying the problem, or are you having a little chitty chat? Chit chat. What is that face? So much drama in your face, Hannah. You know?
Was 1 over 500?
Because I multiply both sides by 500. Oh, right here? The same thing as 1 over 500 times y.
I just say I'm drama.
Y over 500, same thing as 1 over 500 times y. And then it's a constant. I can just multiply. Just multiply by it. Okay, we know a bunch of these things already. It's literally 500 times secant of pi over 4 squared times 0.14.
I have a question. How do you get? I understand the derivative, but is that just factoring it out, or
Which one?
From see the part in black when we go from step 1 to step 2? I don't.
Here?
Yeah.
Multiply both sides by 500.
Why?
To get dy dt by itself, we try to solve for it.
How do we know we're trying to solve for it?
Because it said on the top, it said,
How fast is the balloon?
how fast is the balloon rising? Rising is up and down, so I want to know how is vertical changing with respect to time.
Oh, I don't know.
Yeah. Okay.
I have a question. Yes, going back one step, I still don't get how, like, because it's a constant, you don't have to.
It's literally, it's kind of like if you have 1/2 y, 1/2 x, the derivative is 1/2, right? 1/2, 1/500, y is 1/500 times the derivative of y.
Oh, okay. Okay.
Okay, so I plugged in theta, I plugged in d theta dt, right up here, here we go.
Secant pi over
Secant of pi over 4, that's 45 degrees. So, I will show you over here. So we know, right, cosine of pi over 4 is root 2 over 2. So that means secant, right, the reciprocal function of pi over 4, the reciprocal of cosine, right, secant of pi over 4 is going to be 2 over root 2. So if I rationalize this, 2 root 2 over 2, aka just root 2. So if I take 500 times root 2 squared times 0.14, plug it into your calculator, we find dy dt is going to be 140 feet per minute. Because root 2 squared is 2, 2 times 500 is 1,000. 1,000 times 0.14 is 140. Yeah, square root squared cancel out. 2 times 500, 1,000. Move this decimal place over by 3, and there you go. No calculator needed, 140. What? Feet per minute. Bomb.com, cool. No one says anymore than I do. I'm a 90s baby. Let's do this.
Actually text me that.
Who texted you? I didn't text you that.
No, I think someone did. Like
Oh.
my sister actually texted me bomb.com. What?
How old's your sister?
How old was it?
Yeah. Oh, sweet. I'm 20. Okay. That's what Alvin's daughter. Alvin's daughter thinks I'm like 23. She refuses to accept my real age.
Alvin
How old
the
are
boy.
you?
Yeah.
You look 23.
She's
You look like
she's
what?
27.
I just turned 27. Yeah.
Oh,
Wow.
you have like
I'm old.
no lines
Isn't it crazy? She's the same age as his sister.
whatsoever.
Yeah.
No, I don't want to be mean.